Good day, everyone. We are the Group 6, and the topic we are going to talk about is railway engineering. Railway engineering, or also known as railroad engineering, is a branch of engineering concerned with the design, construction, maintenance, and operation of railways. Railway engineering includes elements of civil, mechanical, industrial, electrical engineering, and other railway externalities. It is unique in being concerned with the interaction between moving vehicles and infrastructure. So, railway engineering encompasses a wide range of engineering disciplines like civil engineering, mechanical engineering, industrial, and many more other engineering disciplines. So, what railway engineers do? They possess mechanical design skills and knowledge of propulsion systems that allows them to design train vessels. Railway engineers are frequently on site, either supervising the rail system or in a hands-on capacity. The topics that we are going to tackle under railway engineering are its history, subfields, components, and stations. Let us know first the history and origin of railway engineering. It was said that the earliest form of rail transportation actually dates back to 600 BC. The Greeks made grooves in paved limestone roads to use in conjunction with wheeled vehicles, easing the transport of boats across the Isthmus of Corinth. However, when Romans conquered the Greeks in 146 BC, early railways fell into ruin and disappeared for more than 1,400 years. In 1550s to 1770s, the precursors to modern trains debuted in the early 1550s in Germany with the introduction of wagonways. So, what are wagonways? These are primitive railroads consisted of wooden rails over which horse-drawn wagons or carts were able to move with greater ease than over dirt roads. And uh, by 1770s, wooden rails had been placed with iron ones. These wagonways evolved into tramways that spread across Europe. And until in 1800s, the railways were constructed of cast iron. Unfortunately, cast iron was prone to rust and it was brittle, often causing it to fail under stress. By 1803 to 1804, a man named Samuel Humphrey decided to fund the development of a steam-powered vehicle to replace the horse-drawn carts on the tramways. Richard Trevithick built that vehicle, the first steam-engine tramway locomotive. And by 1812 to 1814, an English inventor, George Stephenson, became a colliery engineer for the Stockton and Darlington Railway line. So the Stockton and Darlington Railway was a railway company that operated in northeast England. And by 1814, he built his first locomotive for them. Not long after, he convinced the owners to try out a steam-powered locomotive. The first effort was named the Locomotion. And Stephenson is credited as the inventor of the first steam locomotive engine for railways, and Trevithick's invention is cited as the first tramway locomotive. By 1820, John Birkinshaw invented a more durable material called wrought iron. Wrought iron is a type of iron that is tough, malleable, corrosion resistant, and ductile. This material is much better than cast iron since it is corrosion resistant. This innovation, although an improvement over cast iron, was still flawed. However, it became the standard until the advent of the Bessemer process enabled the cheaper production of steel in the late 1860s, spark, sparking the rapid expansion of railways not only across America but around the world. And by 1826, Colonel John Stevens is considered to be father of railroads in the United States. Stevens demonstrated the feasibility of steam locomotion on an experimental circular track constructed at his estate in Hoboken, New Jersey. 2 years before, Stephenson perfected a practical steam locomotive in England. In 1853, the country's first railway opened, the first railway in India. In the mid-19th century, the core of the pressure of building railways in India came from London. The first passenger train ran between Boribunder and Tain, a distance of 34 kilometers. It was operated by three locomotives named Sahib, Sultan, and Sid and had 13 carriages. In 1857, a named Robert Mainland Brereton, a British engineer that took place the expansion of railways formed in 1857 onwards. In 1864, the Jamalpur workshop, the first railway workshop, was established at Jamalpur near Munger, Bihar in 1862. And in 1864, the North got its first station, the Delhi Junction. It is the oldest one of the cities in India and was a major station and junction and remained so till date. In 1881 to 1883, electric tram lines began gaining popularity first in Europe and later then in the United States. After the first made its appearance in 1881 in Lichterfelde, just outside Berlin, Germany, by 1883 an electric tram was running in Britain, England, and the tram that launched service near Vienna, Austria, the same year was the first in regular service to be powered by an overhead line. And by 1890 to 1897, the first underground electric line was launched by the City and South London Railway in 1890. 5 years later, Frank J. Sprague, an inventor who'd once worked for Thomas Edison, came up with a game-changing multiple unit traction control system, or what we call MU, for trains. These MUs got their first practical installation for the South Side Elevated Road, now part of the Chicago L, in 1897. In 1895, a 4-mile stretch of the Baltimore Belt of the Baltimore and Ohio Railroad that connected to the New York became the first American mail rail line to be electrified. In 1915, the Chicago, Milwaukee Street, Paul, and Pacific Railroad electrified service across the Rocky Mountains into the West Coast. By 1930s, the Pennsylvania Railroad had electrified its entire territory east of Harrisburg, Pennsylvania. In 1918 to 1944, railway lines and equipment were in a pitiful state after the First World War, or the World War I. Reconstruction of the railway infrastructure was completed rapidly. The French National Railway Company, or SNCF, was created in 1937 and electrification began. The reconstruction at that time was again needed after 1939 to 1944 with major modernization of the network. And by 1960s to 70s, there was considerable interest in the possibility of building passenger trains that could travel much faster than conventional trains. From the 1970s, interest in an alternative high-speed technology centered on a magnetic levitation, or maglev, in which cars ride on an air cushion created by the electromagnetic reaction between an onboard device and another embedded in its guideway. Now, 2010 to present, more than 1,000 kilometers of electrified lines will be added to the existing network. This electrification is scheduled for 2000 to 2006 and will involve the opening of new lines including the Eastern Europe TGV and the revitalization of freight routes, which will mean more lorries will be carried on trains. Here in the Philippines, its first railway system was back in the 1890s. The line extending from Manila to Dagupan in Pangasinan, covering 195 kilometers. It served as the bridge between the capital to the towns in the north of Luzon, and more than a century later, modernized train systems are all over the country, serving different key areas and making business and trade more convenient and be efficient. Here we have LRT, or the Light Rail System, MRT, commuter line, and also we have subways.
Good day everyone, I'm Jay Valeriano from Group 6 and my topic is all about subfields. So what is subfields? This high-tech discipline includes a range of engineering disciplines like in civil engineering, computer engineering, electrical engineering, mechanical engineering, industrial engineering, telecommunications engineering, and other railway externalities. So it encompasses a wide range of engineering disciplines kasama na nga rito ang civil engineering, mechanical, electrical engineering and command, control and railway signaling. So ang railway engineering offers substantial economic benefits, energy efficiency, and environmental and safety benefits to nations all over the world. And rail is widely viewed as a vital component of the integrated transportation system for sustainable and resource-efficient societies of the future. At itong mga subfields na ito ay matutulong upang mas mapalalim ang kaalaman ukol sa railway engineering at mas mapagtibay at ma-ensure yung kaligtasan ng mga taong masasangkot dito. So we have the civil engineers. Concerning railways, a civil engineer looks for maintenance of assets and bridges, tracks, buildings, and roads of the railway. Besides, there are other positions available for civil engineers who are responsible for the procurement of various logistics and warehousing needs. Moreover, they look out for drawing and designing of multiple projects and surveys under railways. So alam naman natin na ang civil engineering ay may malawak na sakop. Pagdating sa kanyang mga tinatrabaho, maaari silang gumawa ng mga malalaking buildings, tulay, daan at maging ang daan ng mga tren. Meron ding civil engineer na in charge sa various logistics and warehousing needs. At ang karaniwang ginagawa nito ay sila ang gumagawa o gumuguhit ng mga disenyo o nagle-layout ng multiple project like under railways. Next is the mechanical engineers. Mechanical engineers in railways look for train operations like crew management, motive power ability, traffic restoration, repair, and rolling stock management, and manufacturing, etc. Besides, mechanical engineering jobs in railways will assign you the responsibilities like manufacturing and maintenance of factory, goods, and passengers carriers. Moreover, senior professionals may be employed in the maintenance of engines. So, ang mechanical engineers naman ay more on operations like yung gumagawa ng mga makina o nagme-maintain nito para masiguro ang kaligtasan ng lahat bago ito gamitin. So, ang mga senior professionals ang itinatapat o inilalagay sa maintenance ng mga engines dahil sila yung mas may alam na tungkol dito. Next, we have the electrical engineers. So, ang electrical engineers will look for assets in the electrical department of railways. The roles of responsibilities include maintenance of electrical multiple units, locomotives, traction, distribution, and maintain electric multiple unit. The senior professionals take care of manufacturing and maintenance of the factory and signal-related jobs. They might also involve in planning department duty and preservation of the engine. So, ang mga electrical engineers naman ay ang kanilang forte ay ang electrical department for railways. Kasama sa kanilang trabaho ang maintenance ng electrical multiple units, yung distribution ng linya ng electricity. So, dito, ang mga senior professionals ay nangangalaga sa manufacturing and maintenance ng factory and signal-related jobs at sila rin ang involved sa pagpaplano ng kanilang departamento sa kanilang trabaho ukol sa pagpe-preserve at pagpapanatili ng kaayusan ng mga engines. So next we have the command control and railway signaling. Direct control switching systems, step by step, do not allow for separation of the supervisor and address signaling functions. The dialed address positions of the switches directly. The numbering scheme controlling the routing of call connections. The supervisor and address signaling functions are combined in the network line signaling system. The signaling limit tends to be limited by the permissible and decadic address pulse distortion. So dito nakapaloob ang mga dapat dapat nating pindutin upang makontrol yung signaling systems ng railways. So this figure generalized principle of common control switching. So in common control switching, permit separation of the supervisor or yung line and address or yung selection signaling functions over the network. In common control switching, the common control equipment, so yung register translator and marker, deals with the call connection set up through the switch block being released from a call on common connection establishment to deal with other call connections. The marker controls the switching. So the incoming line in the incoming mark at the switch block. Address information inputs the register which refers to the translator. The resulting translation establishes the outgoing mark identifying the outgoing line. The marker switches the two marks together through the switch block. The translation facility permits automatic alternative routing. So for the figure 2, the line and inter-register signaling. A railway signaling system mainly includes a train control system, an interlocking system (CTC), and a centralized signaling monitoring system. The existing signaling system is the result of a long period of development and continuous improvement of meeting the needs of train control and dispatching command, improving the efficiency and ensuring the train safety. In this process, the principle of system science has been partly reflected in the signaling system. Consequently, the signaling system performance has improved. The application of system science belongs to the initial stage in the signaling system, and yet there remains great room for development.
Good day, everyone. I'm the next reporter, John Rodrizli Umali. So, our first bullet is about light rail systems. Light rail or light rail transit (LRT) is a form of urban rail public transportation that generally has a lower capacity and lower speed than heavy rail and metro systems, but higher capacity and higher speed than traditional street-running tram systems. The term is typically used to refer to rail systems with rapid transit style features that usually use electric rail cars operating mostly in private rights of way, separated from other traffic but sometimes if necessary mixed with other traffic in city streets. So if this is the case, then under the law of many countries, such systems are then legally tramways, although the vehicles which run on them are sometimes designated super trams. Modern light rail technology is flexible and adaptable, and whether any given system is considered a true rapid transit system or not depends on its characteristics. So, we are all familiar naman with LRT, and we know that it is more commonly or mostly used in our capital, which is Metro Manila. So, next slide, comparison to other rail transit modes. With its mix of right-of-way of types and train control technologies, LRT offers the widest range of latitude of any rail system in the design, engineering, and operating practices. So the challenge in designing light rail systems is to realize the potential of LRT to provide fast, comfortable service while avoiding the tendency to over-design that results in excessive capital costs beyond what is necessary to meet the public's needs. So, alam naman natin na an LRT can take you to where you want to go faster and more cost efficient. Tapos, mas marami pang passengers yung kaya niyang i-cater. So, on to our next bullet, on-track plant. On-track plant or OTP refers to machinery designed to run on the railway. These machines are leading the way with technological advancements to save time, money, and of course, improve safety. Kaso, however, they do still pose a significant risk to people working on or near them. Always make sure you understand the risk before going to work with OTP. So, lahat naman ng bagay sa paligid natin, may mga possible risks pa rin siya. So, we just need to be careful and need natin ma-make sure na aware tayo sa mga risks na kakaharapin natin. On to our next bullet, which is the rail systems integration. Since dirt roads with horse-drawn carriages and wagons were replaced with rails, rail transit systems were built from the top of running rails or TOR and center line of rails or COR. TOR is the interface of rails car, vertical clearances with overhead structures, passenger car, vestibule, interfaces with station platforms. COR is the interface for horizontal clearance between rail cars and structures along the right of way or the road. So, rail transit industry evolved to steel rails and cars with steel wheels and axle sets. From this foundation, operators continued to integrate technology and raise service standards by adding systems to improve the safety of train operations and comfort in passenger cars and fixed infrastructure. Each improvement created more interfaces and the need for more extensive testing of interdependent systems assure operation to meet standards. So, lahat naman ng innovation sa technology natin, it aims to make our lives easier and more comfortable. So, some of the interfaces na tinutukoy doon are AC and DC, electric motor propulsion, and passenger HVAC comfort on rail cars, third rail DC power and AC overhead catenary power to support passenger cars. Next is the 110 Hz AC powered signal systems for safest movement rail cars. Next is and last is the communication systems for operations and customer information at stations and on board rail cars. So, yung mga yon yung mga interfaces na tinutukoy doon sa ating rail systems integration. So our next bullet is about train control systems. Train control systems are the hardware and software equipment that monitor train locations and movements in order to ensure safety. So kahit sabihin natin mas convenient and mas mabilis tayo makakarating sa mga trains, syempre may mga control system sila para ma-ensure natin na meron tayong proper monitoring of our safety and our location. So there are different systems of train control systems. So first is the communications based train control systems or the CBTC systems. So ano nga ba 'yon? They are high resolution train location determination independent of track circuits. They have continuous high capacity bidirectional train to wayside data communications. And lastly, they are train-borne and wayside processors performing vital functions. So ito yung mga inclusions ng ating CBTC system. So next is the positive train control systems or the PTC system. So ano ba yung mga characteristics naman ng ating PTC? So different from the CBTC, PTC has a train separation or collision avoidance, line speed enforcement, temporary speed restrictions, and rail worker wayside safety. So ito yung inclusions nung sa PTC. So ito pinagtabi sila para magkaroon tayo ng comparison sa dalawang systems ng train control systems. On to our next bullet is the cab signaling. Cab signaling is a railroad safety system that communicates track status information to the train cab or the driving position, where the engineer or driver can see the information. The main purpose of a signal system is to enforce a safe separation between trains and to enforce speed limits. So, pati dito sa cab signaling, we're still talking about the safety. We're still uh, involved about the safety. So, sabi dito, yung main purpose niya is to enforce a safe separation between trains tapos mag-set siya ng mga speed limit. So, parang siya din yung nag-i-indicate ng mga speed limits na yon. They are the simplest systems display the track side signal aspect, typically green, yellow, or red, indicating whether it is safe to proceed or not. So, parang sa normal roads lang natin, traffic lights na nag-i-indicate kung pwede na ba tayong huminto, pwede na ba tayong dumiretso o mag-slow down. So, sa train stations, may mga ganun din. So, next is sophisticated systems also display allowable speed, location of nearby trains, and dynamic information about the track ahead. So, dito, mamamonitor mo rin kung ano ba yung allowable speed dun sa location na yon or kung meron bang malapit na train sa'yo, pwede mo rin yun mamonitor dito using the cab signaling. It is included here. So there are three classes of cab signal systems. So first is the wayside signals that intermittent warning and enforcement capabilities, continuous cab signal and speed enforcement systems, and positive train control PTC and other new technology systems. So ito yung mga classes of cab signal systems, yung tatlo na to.
So next subfield is rolling resistance. Rolling resistance, or also called as rolling friction, is a combination of forces that work against the forward motion of the vehicle. It is the force that resists the motion of the body rolling on a surface. Sa vehicle, kapag umandar na, ang nakakapagpabagal dito ay rolling friction. The more rolling resistance, the more power it takes to propel a vehicle. The pure rolling resistance for a train is that which happens due to a deformation and possible minor sliding at the wheel road contacts. Under rolling resistance, mayroong resistive forces. So, una, rolling friction between wheels and rail ay nakadepende sa quality ng truck or yung dinadaanan ng train. Pangalawa, yung bearing resistance, that which varies with the weight on each axle and at low speed, the type, design, and lubrication of the bearing. Pangatlo ay train dynamic forces that includes the effects of friction and impact between the wheel flanges against the gauge side of the rail and those due to sway, concussion, buff, and slack action. So, yung flanges ay makikita sa daan ng tren yung truck. So last is the air resistance that varies directly with the cross-sectional area, length, and shape of the vehicle and the square of its speed. Under rolling resistance, we have curve resistance. Curve resistance depends on radius of curve and gross weight of vehicle and velocity at which vehicle starts moving. A train must overcome when traveling on a curved section of track. Most railways are described in terms of piecewise curves. The two main types of segments, namely straight lines and circular arcs, are connected together via transition curves. So, curve resistance is caused due to first, the flange of the outer wheel of the leading axle rubs against the inner face of the outer rail, causing resistance due to sliding friction. So second, the outer wheel rotates faster than the inner wheel, causing transverse slip, thus adding to sliding friction. So last is less super elevation causes increased pressure on outer rail, whereas higher super elevation results in increased pressure on the inner rail, thus increasing curve resistance. So next subfield is wheel-rail interface. The wheel-rail interface is an area of contact between wheels and rails of railways. The interaction between wheel and rail is a specialized subject covering the design and management of high stresses in the small contact area between steel wheel and steel rail. The wheel tire is coned and the rail head slightly curved. The rail are also set at an inward angle. The surface of a wheel that rests on the rail is known as the tread. Wheels may have either a single flange on the gauge side of the rail or two flanges, one on each side of the rail. So under wheel-rail interface, we have hunting oscillation. A classical hunting oscillation is the swaying motion of a railway vehicle, often called track hunting or boogie hunting, caused by the conning section on which the directional stability of adhesion railway depends. It arises from the interaction of adhesion forces and inertial forces. At low speed, adhesion dominates. But as the speed increases, the adhesion forces and inertial forces become comparable in magnitude and the oscillation begins at the critical speed. So last subfield is railway system engineering. At under doon merong 5. Una doon yung railway signaling. The purpose of signaling system is to ensure safe movements of train on a railway infrastructure by locking movable track elements in a proper position, check the clearance of track sections, locking out conflicting moves, and control train movements in a way to keep them safely apart. Railway signaling ay para sa safety ng pagtakbo ng train. Nagbibigay ng signal sa driver upang alam ng driver yung gagawin. May mga iba't ibang ginagamit para sa signaling. May iba't ibang signals. Una na dito yung fixed signals. Indication are displayed by colored lights such as red, green, and yellow. Clear indicated by a green light. Caution indicated by a yellow light. Stop indicated by a red light. Caution and clear are signal aspects that gives rail traffic crew the authority to proceed. So next is hand signals. Include signals given by hand or by flags or lamps used by signalmen, drivers, guards, and station staff. Gumagamit sila ng flags na may kulay green and red. Green flag ay nasa kaliwang kamay, while red flags ay nasa kanan, in case na may mangyaring problema. So next is detonating signals, known as detonators or fog signals, are appliances which are fixed on the rail and when an engine or vehicle passes over them, they explode with a loud report so as to attract the attention of the driver. So next is flare signals, includes a fuse emits a bright red flame when lighted and is used for warning the driver of an approaching train of any obstruction such as floods, landslides, and etc. So next sa railway signaling is fare collection, the fee paid by passenger for use of public transport system. Meron binabayad kapag sasakay sa anumang transportation. Kukuha ka ng ticket na siyang magiging pass mo para makasakay. So next is CCTV, stands for closed circuit television. It is primarily used for security, monitoring, and surveillance purposes. It provides visual monitoring of railway premises and information to passengers. CCTV used to ensure enhanced safety and security at railway premises. So next is public address system or PA system, an electronic sound amplification and distribution system with a microphone, amplifier, and loudspeakers, used to allow a person to address a large public. For example, for announcement of movements at large and noisy air and rail terminals. The simplest PA system consists of microphone, an amplifier, and one or more loudspeakers. So next is Intrusion Detection System or IDS. Also known as Intrusion Protection System or IPS, is a device or software application that monitors a network or system for malicious activity or policy violations. It is a monitoring system that detects the suspicious activities and generates alerts when they are detected.
Now let's proceed to the different components of a railway track. But before we discuss the different components of a railway track, let us first define what is a railway track. So a railway track is also called a permanent way, is defined as a combination of rails fitted on sleepers and resting on ballast and subgrade. The typical components are rails, sleepers or ties, fasteners, ballasts or sub slab track, and subgrade and embankment. So from the definition, uh, we can deduce that a railway track as one of the focal points in the study or in the field of railway engineering is a combination of its different components such as rails or sleepers. So, ibig sabihin, binubuo siya at hindi siya matatawag na railway track when one of its component is missing. From the figure, we can notice yung iba't ibang components itong railway track starting from the rails on the uppermost part of the figure. Then, susunod yung sleepers, where the uh, rails is fitted and directly under the sleepers are the ballast and sub-ballast. Then, we have the last component on the lower part of the figure, which is the subgrade and embankment. So let's proceed to the first component of a railway track. The first component of a railway track is the rails. So the rails provide a hard, smooth, and unchanging surface for the passage of heavy moving loads. Rails are made of high carbon steel to withstand wear and tear. Flat-footed rails are mostly used in railway track. So the rails uh, is one of the most important part of a railway track because it's responsible for transferring load from wheel safety to the sleepers and ballast, which is directly beneath the rails, and it is also responsible for providing a smooth level surface for the movement of trains. We know that yung railway track is yung dinadaan ng mga tren, so it is responsible for the smooth level surface sa movement o sa dadaanan ng mga tren, and it because it guides the wheels of trains throughout the trackway. So it is made from carbon steel, which is known for its high strength, stiffness, and durability. So it has different functions. So the rails provide a continuous and level surface for the movement of the trains with minimum friction with steels of the rolling stock. It also provides strength, durability, and lateral guidance to the track. It transmits the axle load to sleepers, which transfers the same load to the underlying ballast and formation, and it bears the stress developed due to heavy vertical loads, braking forces, and temperature variance. So, from the different functions, we can deduce that one of the most important functions ng rails is to bear the loads because as the train moves in a railway track, syempre mabigat yung dala-dala niya and malaki yung force na kailangan withstand and yung rail yung responsible to withstand those wear and tear forces. So it is responsible para maging smooth yung pagta-travel and pag-move nung train. So the rails have different types and it is composed the different types of rails are the double-headed rails, the bull-headed rails, and the flat-footed rails. So let's first discuss the first type of rail. Double-headed rails is a rail section whose foot and head are of the same dimensions. In the beginning, these rails were widely used in the railway track. The idea behind using these rails was that when the head had worn out due to rubbing action of wheels, the rails could be inverted and reused. But by experience, it was found that their foot could not be used as running surface because it also got corrugated under the impact of wheel loads. So this is the type of rail where both the upper and lower tables are identical, and they were introduced with the hope of doubling the life of rails. So from the figure, we can see that the upper part and the lower part is identical or they are equal in size. So this is for the this is the reason kung bakit na naisip nila na baka madoble yung buhay nung rails or yung usage nitong rails. Pero napatunayan din nila doon na hindi na pwedeng gamitin yung yung lower part after maano yung upper part dahil na na worn out na rin ito after na ma-worn out nitong nasa taas. The second part of the second type of rail is the bull-headed rails. So it is a rail section whose head dimensions are more than that of their foot are called bull-headed rails. In this type of rail, the head is made little thicker and stronger than the lower part by adding more metal to it. These rails also require chairs for holding them in position. Bull-headed rails are especially used for making points and crossing. So these rails are usually formed from steel. And kung mapapansin natin sa figure, its head o yung nasa taas niya is mas malaki compared dun sa sa lower part or nasa baba. So compared to the double-headed rails, hindi proportional yung or hindi equal yung size ng upper and lower tables nito. So thus, the foot is designed only to furnish necessary strength and stiffness to rails. Then the last type of rails is the flat-footed rails. So the flat-footed rails, it is a rail section having their foot rolled to flat, and it is also called Vignoles rails because it was invented by Charles Vignole in 1836. It was initially thought that the flat-footed rails could fix directly to wooden sleepers and would eliminate chairs and keys required for the BH rails, but later on it was observed that heavy train loads caused the foot of the rail to sink into the sleepers and making the spikes loose. To remove this defect, steel bearing plates were used in between flat-footed rails and the wooden sleepers. So this is a type of rail where the foot is spread out to form a base. This form of rail has become so much popular na kung saan nga umabot ng 90% of the railway tracks around the world ay meron itong type of rail na ito. So kung mapapansin natin from the figure na mas flat-footed yung kanyang lower part. So ito nga daw is for the reason na ah, para ma-fix directly dun sa wooden sleepers and ma-eliminate yung paggamit ng chairs and keys. So those are the three types of the rails. Now, let's proceed to the rail joints. So a rail joint is an integral part of a railway track because it holds together the adjoining ends of rails in correct position, both in horizontal and vertical planes. So a rail joint, isa rin ito daw important na parts ng isang railway track. So a rail joint is the weakest link in the trunk. At the joint, there's a break in the continuity of the rail in both the horizontal and the vertical planes because of the presence of the expansion gap and imperfections in the levels of rail heads. A severe jolt is also experienced at the rail joint when the vehicles will negotiate the expansion gap. This jolt loosens the ballast under the sleeper bed, making the maintenance of the joint difficult. The fittings of the joint also become loose, causing heavy wear and tear of the track material. So as defined, it is one of the most important part din ng isang railway track because it adjoins or kinoconnect niya yung end of rails in correct position para hindi sila paleng both in horizontal and vertical aspects. So it also has different type. So it is classified according to the position of sleepers and according to the position of the joint. So let's first discuss the classifications according to the position of sleepers. So the first type of rail joints according to position of sleepers are the supported joints. In this type of joint, the ends of the rails are supported directly on the sleeper, called as joint sleeper. The support tends to slightly raise the height of the rail ends. As such, the run on a supported joint is normally hard. There is also wear and tear of the sleeper supporting the joint, and its maintenance presents quite a problem. The duplex sleeper is an example of a supported joint. So, this rail joint is placed at the center of the two consecutive sleepers, and it is claimed that yung load is equally distributed on two sleepers. And when the joint is depressed, both rails ends are pressed down. However, this type of rail joint is known to cause more maintenance. So, mas mahal daw kapag i-maintain yung mga ganitong supporter joints. Pansin natin sa figure na example ng isang supported joint. So, makita natin yung mga joints where it is placed at the center. So, kita natin doon sa center where the arrow is pointing towards. So, we can see that the rail joint is placed at the center of two consecutive sleepers. So, there are two consecutive sleepers and then there is that is where the joint is placed at the center of the consecutive sleepers. So, next is the suspended joints. In this type of joint, the end of the rails are suspended between two sleepers and some portion of the rail is cantilevered at the joint. As a result of cantilever action, the packing under the sleepers of the joint becomes loose, particularly due to the hammering action of the moving train loads. Suspended joints are the most common type of joints adopted by railway systems worldwide. So this type of rail joint, of course, when the sleeper is placed exactly below the rail joint, this type of joint is found from experience that gives sufficient support with heavy axle load. So the last type of the rail joint, according to the position of the slipper, is the bridge joint. So the bridge joint is similar to the suspended joint, except that the two slippers on either side of a bridge joint are connected by means of a metal flat or a corrugated plate known as a bridge plate. So similar lang din daw siya in terms of composition or yung figure niya. Parehas lang sila halos ng suspended joint kung ating titignan. Pero ang pinagkaiba niya is the length of metal serving as bridge Yun yung ginagamit to connect the end of two rails para walang maging bending stresses dun sa rails. So to rest the bridge on two sleepers, they are not headed out. However, an experiment have shown that this type of joint ay hindi possible sa actual practice. So presently, hindi siya masyadong ginagamit or uh, favored by railway engineers. So kung mapapansin natin yung figure, there are two types then ng bridge joint. Yung isa, yung with metal flat joint, mapapansin naman natin, yung metal is in flat. Tapos sa pangalawa, the bridge joint with bridge plate. So it is in the shape of bridge and the other one is flat in shape. So yun lang yung kanilang pinagkaiba. But they serve the same purpose as a bridge joint. So those are the three classifications based on the position of the sleepers. Now, let's proceed to the classifications based on the position of the joint. So there are only two types of rail joints that fall in this category. So the first type of rail joint is the square joints. In this case, the joints in one rail are exactly opposite to the joints in the other rail. This kind of joint is suitable for the straight rail line. And the rail line can be laid mechanically section by section. So kapag dumadaan yung mga trains, yung two opposite joints ay sila yung nagbe-bear ng impact force at the same time dahil nga exactly opposite sila or magkapantay sila. And dahil magkapantay sila, nare-reduce nito yung number of hits to the rail track. The running of the train will be more smooth. At present, madalas itong ginagamit sa railway lines. So kung mapapansin natin yung figure, yung square joints, ayan, dalawa silang opposite joints that are exactly opposite with each other. So magkapantay sila, nasa magkabilang side sila at the exact position. So, yun yung square joints. The second type is the staggered joints. In this case, the joints in one rail are somewhat staggered and are not opposite the joints in the other rail. Staggered joints are normally preferred on curved tracks because they hinder the centrifugal force that pushes the track outward. So pagdating naman dito, yung distance between the two opposing joints, staggered half a rail. So madalas nga siyang ginagamit sa mga curved rail lines dahil nadidisperse niya yung impact force from the rolling of the wheels. However, because of the same reason, hindi siya recommended for stability purposes. So kung mapapansin natin, yung figure na, or example lang, staggered joints, mapapansin natin it is usually used in curved rail lines. Just like from the figure, it is because hinder niya yung centrifugal force or yung force that is caused when a body is rotating or when there is a motion of rotation. So those are the two different types of rail joints or classifications based on the position of the joint.
Sleepers. The support which keeps the rails apart at required distance. Support the rail and distribute the load of the ballast or cold sleepers. Sleepers are different materials such as wood, steel, cast iron, RCC, and T-stress concrete. Sleepers are concrete beds in the railway tracks. It is the second main important thing in railway track components. They are fixed vertical to each other and throughout the main track. The main work of sleepers is to hold rails in a strong position and receive loads from the rails and spread to ballast and subgrades. So yung sleepers yung makikita nyo sa railway tracks na vertically positioned between railways, sa ilalim siya ng railways. Ang yung pinaka work niya is yung i-hold niya yung rail sa isang strong position at siya yung mag-receive ng loads ng mga dumadaan ng mga sasakyan or yung train. So what are the functions of sleepers? So the important function of sleepers are the first one, to hold the rail's proper gauge in all situations. So that is exact, gouge along straight and flat curves, slightly loose on sharp curves, and slightly tight in diamond crossing. So yung function niya talaga is to hold the rails together. Yung yung rails in Tagalog. So sa mga iba't ibang pakurbada, sa mga sharp curves, sa mga slight na liko, pwedeng nakalose sila ng onte. So they are the one that keeps the rail together. To support the rails firmly and evenly throughout. To distribute the load transmitted through the rails over large area of ballast underneath to the bridge girders. To hold the rails to proper level in turnouts and crossovers, and at 1 in 20 in a wide slope along straight tracks. So to provide an elastic medium between the rails and ballast, and also to absorb the vibration caused due to moving axle loads. So since sila nga yung nakailalim sa may naka-align sa may rails na nag-hold sa kanila, so sila yung nag-absorb ng mga vibration due to moving of axle loads or yung mga pagdaan nga kasi ng mga dumadaan dun. To maintain proper alignment of the track, on curve, proper cant is provided by raising the outer rail and pumping the required quantity of ballast below the rails. So sila nga yung nagme-maintain din ng proper alignment of the track since yung mismong track is the rails, the railings. So they are the one that holds together the rail and keep the fixture of it to provide the general stability of the permanent way throughout. So yung stability din ng railway, to provide the installation of track for the electrified for signaling, to provide is replacement of the rail fastenings without any serious traffic disturbances. So there are types of sleepers. The first one is the wooden sleepers. These sleepers are regarded to be the best as they satisfy all the requirements of a good sleepers and are the only one sleeper suitable for track circuiting. So as it said, yung wooden sleepers nga daw yung sleepers since they satisfy all the requirements of a good sleepers. The life of a wooden sleepers depends upon their ability to resist wear or yung mga atake ng mga puting langgam na pwedeng makasira nga ng quality or ng lifespan ng wooden sleepers at saka yung quality ng ginamit na timber. Steel sleepers. This sleeper consists of steel through made of 6 mm thick sheets with its both ends bent down to check the running out of ballast. At the time of the pressing of sleepers, an inward slope of 1 in 20 on either side is provided to achieve required tilt of rails. The standard length of this is 2,680 mm. Cast iron sleepers. The sleepers made of cast iron, known as cast iron sleepers, have been extensively used in India as compared to other countries in the world. So ito yung mga type of sleepers na ginagamit mostly sa India. RCC sleepers, or drain for cement concrete sleepers, are of two types. The first one is the true type. This is also known as the one-piece or mono-block sleeper. In this type of sleeper, cracks develop on tension side when stressed. Those cracks are very small and almost invisible, but tend to enlarge with the repetition of impact loading, causing the failure. Since true type siya, so ibig sabihin nandun siya sa may likod. So, nagkakaroon siya ng tensile or ng tensile stress sa dalawa na yun, and magkakaroon siya ng mga crack. And yung mga crack na yun, hindi naman siya sobrang laki, almost invisible naman sila. Pero syempre, due to workload or sa paulit-ulit na impact ng pagdaan, nagkakaroon siya ng failure. The next type is the block and tie type. This type of sleeper consists of two RCC blocks connected by a metal tie of inverted T section. These sleepers are not subjected to any degree of tensile stress as in true type. Pre-stressed concrete sleepers. These sleepers have high initial cost but are very cheap in the long run due to their long life. In these sleepers, high-tension steel wires are used. These wires are stretched by hydraulic jack to give necessary tensions in wires. The concrete is then put under a very high initial compression. These sleepers are heavily damaged in the case of derailment or accidents of trains. So, ibig sabihin concrete, so ibig sabihin cement siya. Alam naman natin na yung cement due to continuous vibration, malaki yung tendency na magkaroon ng breakout or magkaroon ng break. So, Kagaya nga ng sinabi dito, yung wood, maganda siya kasi pasok siya sa good quality of sleepers. Nasa-satisfy niya lahat ng good quality. But then, yung lifespan niya nga, yung magdedetermine lang nun kung gaano katagal tatagal yun. Fastening in railway rigid, member of components of railway track, fastening or fixtures. Fastening in railway is used to connect the rails and sleepers together in their proper positions. The main function of rail fastening system is preventing steel rail from lateral and horizontal movement. So yung pinaka-main function nga niya is yung to prevent yung steel rail sa lateral and horizontal movement. Besides that, rail fastening system also can absorb and transfer the pressure from locomotive to railway sleeper. In a word, rail fastening system ensures the rail engage and protects rail safety. Rail fastening system has a lot of types that is composed of different fasteners. So, functions of fastening in railway. Fastening in railway has the following functions. First one is join the rails end to end full from length to track. Fix the rails to sleeper. So yung yung isipin nyo, yung fastening, ay yung fastener na nilalagay sa folder is just like the fastener na nilalagay sa mga railway tracks na pang fix. Kung yung fastener na nilalagay sa folder is pang fix ng mga papers, ito naman pang fix ng railway. To maintain the correct alignment of the track, to provide proper expansion gap between rails, to maintain the required tilt of rails, to set points and crossing in proper position. So the fixtures and fastening used in track fittings are fish plates, spike, bolts, chairs, blocks, keys, and plates. Fish plates. Fish plates are used in rail joints to maintain the continuity of the rails. These are manufactured of steel and are so designed that they fit in between the head and foot of the rail. Spikes are used to fix rails to wooden sleepers. Spikes are the following types. The first one is dog spikes. These are the cheaper type of spikes which hold the rails at correct gauge and can be easily fixed and removed. These are commonly used for FF rails. Round spikes. Round spikes are used for fixing chairs of BH, rails to wooden sleepers, and also for fixing slide chairs of points and crossings. These have either cylindrical and hemispherical head or blunt end. Screw spikes are tapered screws with V-threads. Their head is circular with a square projection and are used to fasten rails with wooden sleepers. The holding power of these spikes is more than double of that. Dog spikes can resist the lateral thrust better than the dog spikes. Elastic spikes are used for fixing FF rails to wooden sleepers. This gives better grip and result in reduction of wear and tear of rail. The advantage of the spike is that it's not pulled up by the wave action of the moving train. So, ibig sabihin, elastic nga, so they can move freely. So, hindi nga sila agad ma-pulled by the wave action pagka dumadaan yung mga train din sa railway. Kasi nga, di ba, they can align with the movement of the railways. The next one is the bolts. Bolts are different. There are different types of bolts that are used. The first one is fish bolts, used for connecting fish plates with the rails. The second one is the hook bolts, are also known as the dog bolts due to the shape of their heads. These bolts are used to fix the sleepers which rest directly on a girder. Fang bolts are used for fixing side chairs to sleepers. These are alternative screw or round spikes. Keys. These are small tapered pieces or timber used steel to fix rails on metal sleepers. Ballast. Ballast is a broken stone paste or pack below the sleepers or transmit load from sleeper to the formation at the same time, allowing drainage of the track. So they are the drainage of the track of the railway. So para silang subcomponents of ng ground na pinaglalagyan ng railway. Function of ballast. First one, to provide firm and level bed for the sleepers to rest on. So yun nga yung level bed para mas maging matibay. To allow for maintaining correct track level without disturbing the railroad bed. To drain off the water quickly and to keep the sleepers in dry condition. So, di ba drainage nga siya. So, they drain off water quickly. So, yung sleepers magiging tuyo. Kasi di ba yung kagaya nga yung sleepers nga daw yung high quality. So, one factor din yan ng tubig pagka na-imbakan yung mga kahoy, maaaring magkaroon nga ng mga white ants. To discourage the growth of vegetation, so yun para hindi magkaroon ng mga ugat-ugat pa, baka kasi madaling masira yung mga sleepers dun. To protect the surface of formation and to form elastic bed, to hold the sleepers in position during the passage of trains. So, hold niya din yung mga sleepers pagka dumadaan nga, di ba, due to vibration, maaaring magkaroon ng movement pagka dumadaan yung mga tren or mga sasakyan dun sa railway. So, to transmit and distribute the loads from the sleepers to the formation. So, instead of sleepers, dun sa mga formation or dun sa mismo sa may subside na pupunta yung loads, provide lateral stability for the track as a whole. So, stability nga sa buong railway. Last one is subgrade and embankment. Subgrade is the normally occurring ground which when we prepare to receive the ballast, the blast and track is called formation. So yung subgrade nga yung occurring ground kung saan tinatayo at yung pinaprepare natin na ilalagay yung railway. In a permanent way, rails are joined either by welding or by using fish plates and are fixed with sleepers by using different types of fastenings. Sleepers are properly placed and packed with ballast, and ballast is placed on the prepared subgrade called the formation. So ito nga yung pinaglalagyan, yung subgrade the embankment, yung pinaglalagyan ng ballast. So that's where the importance of subgrade is. So yung pinaka-importance nga niya kasi, parang siya yung magre-receive ng lahat, ng blast, ng track. So yung yun nga yung pinaka-formation ng railway ng nagagawin.
Let's move on to railroad station. A railway station is a place on a railway line where traffic is booked and dealt with, and where trains are given the authority to proceed forward. Sometimes only one of these functions is carried out at a station, and accordingly it is classified as a flag station or a block station. In case of a flag station, there are arrangements for dealing with traffic but none for controlling the movement of the trains. In case of the flag station, a train cannot proceed further without obtaining permission from the next station, and traffic may or may not be dealt with. We have here the purpose of the railway station. The first one is to entrain or detrain passengers. Ito yung pinaka-common na use ng railway station, yung sakayan at babaan ng mga pasahero. Next one is to load or unload goods or parcels. Ginagamit din ito para ikarga o i-load yung mga goods or parcel hanggang ma-ship ito. Next one is to control the movement of trains, to enable trains to cross each other in case of a single line section. Meron kasing part na 2 lane siya, tapos sa dulo magiging 1 lane na lang. So yung railway station yung mag-provide ng decision kung sino muna yung papadaanin, then saka pala mag-proceed yung another one. Next one is to enable faster trains to overtake slower ones. Yun nga, nasa railway station yung control kung sino yung, kung papayag sila na ma-overtake kan yung isa. Next is to enable locomotives to refuel, whether it be diesel, water, or coal. Another purpose is to attach or detach coaches or wagons to trains. Yung mga wagons na to, usually ito yung may sakay ng mga goods and animals. Next one is to collect food and waters for the passengers. Siyempre, maganda pa din na may ganitong facility para maganda yung service nila. Next one is to provide facilities for change of engines and crews or staff. Mahalaga din na may sariling facility yung mga crews and staff natin, tsaka yung pag-repair dun sa train. Next one is to enable sorting out of wagons and bogies to form new trains. Next is to provide facilities and give shelter to passengers in case of emergencies such as floods and accidents which disrupt traffic. Yun nga, sabi ko kanina, maganda yung may facility na ganito para in case nga ng emergencies, may mapupuntahan yung mga passenger kung hindi sila makauwi sa mga papuntahan nila. Now, let's talk about the selection of site for a railway station. Siyempre, sa pag-select ng railway station, may mga factors din tayo na kino-consider. Hindi pwede yun na pag sinabing gusto ko dito magtayo ng railway station, dun agad. Ito yung mga kailangan natin. The first one is the adequate land. There should be an adequate land available for the station building, not only for the proposed line but also for any future expansion. The proposed area should not also be without any religious buildings. Ayun nga, pag nag-propose ka, hindi pwedeng yung exact land lang kasi malaki yung possibility na mag-expand yon. Tsaka dapat hindi nito madadaanan yung mga religious buildings such as yung churches. Next one is the level area with good drainage. The proposed site should be preferably be on a fairly level ground with good drainage arrangement. It should be possible to provide the maximum permissible gradient in the yard. Parang sinasabi lang dito na kailangan may drainage pa rin tayo para hindi maipon dun sa railway station yung mga tubig. The next one is the alignment. The station site should preferably have a straight alignment so that the various signals are clearly visible. The proximity of the station site to a curb presents a number of operational problems. Parang mas maganda daw yung makukuha natin na land is yung diretso lang para makita yung mga signal, and yung curve kasi pwede siyang mag-cause ng mga problem. Next one is the easy accessibility. The station site should be easily accessible. The site should be near villages or towns. Nearby villages should be connected to the station by means of approach road for the convenience of passenger. Siyempre, mas maganda nga naman yung malapit sa village and town para madaling ma-access ng mga tao na gustong bumiyahe. And the last one is the water supply arrangement. When selecting the site, it should be verified that adequate water supply is available for passengers and operational needs. Siyempre, importante yung tubig para sa mga nauhaw natin na passengers, or pwede rin gamitin to sa pag-operate ng trains.